Welcome. Well, Aaron and I are both middle school teachers. Aaron, a current middle school teacher, and I was a former middle school science teacher. I retired a couple of years ago. And obviously, so we're pretty excited about using the modeling approach in teaching middle school, and love to share that whenever we can get people interested in hearing a little bit more about it. And what we're going to do today is kind of walk you through a couple of exercises to help you get an idea of what modeling is about, how it works, and why we use it. And next slide there. So as we are going along, we're going to move along at a pretty quick pace. If you have an urgent question, jump in. Just put it out there. If it's a question that you just want to kind of have somebody address at some point, or just want to think a little bit on, go ahead and put it in the chat session. And then at the end of the session, or somewhere in the middle, we'll take a break and go through some of the questions and see what we can uncover with that. Any questions so far? Speaking of which, is everybody able to hear and see and engage? Okay, awesome. Aaron, next, when we're doing modeling instruction for teachers, we often want to try and ask teachers that are learning about modeling instruction to take on a student role. And when we say take on a student role, you obviously are a student, but we want you to actually try and put on your student hat and think the way your students would. Try and kind of crawl inside their skin and their brain and ask yourself, how would a middle schooler respond to this? And that helps get a sense of why this works, and help you, I don't know what's the word. I mean, get connected to how your students might respond as if you were to start deploying modeling instruction in your own classroom. So periodically we'll say student hat. We're going to ask you to actually think like your own students might think. And then periodically we'll have a teacher discussion, colleague to colleague, and we'll ask you to put on your teacher hat and then ask those kinds of questions that you have, or you think other teachers might have, that were being introduced to the idea or trying to do something with it in your school. And well, there's a lot more to go into on that, but I think we won't take too much more tonight. Aaron, is there anything you wanted to add?
No, it's sometimes a little scary to think like students, but that's the pure joy of modeling. Being able to walk in their shoes and try to emulate the idea of, I'm sorry, my dogs are trying to get me through too. Emulate them and modeling for them, what is it like to take risks, and knowing how those risks are going to be supported throughout the process of modeling. So take those risks. That's what we're asking you to do.
All right, and welcome, Michelle Mahoney. Glad to see you. Glad you can join us tonight. So we're gonna, Aaron, let's move on, and the very first thing we're gonna do is an exercise that we have found to be fun and challenging, and particularly working with adults. It's always interesting to me. If you've seen this before, don't give it away. But certainly participate. Just kind of join. Well, I think you'll enjoy it. We'll just do that. Is anybody just off the top of my, well, actually, don't even tell me. We're just going to go ahead and jump in. So this is called Polar Bears, a riddle. I'm going to read the riddle aloud, and then we're going to kind of move in and take a look at what it's all about. Polar bears, they come in pairs. They sit around the hole in the ice like petals around a flower. How many polar bears do you see? How many fish in the sea? What about the plankton? All right, so having said that, this is kind of a dice game. So Aaron, let's pop on. Hopefully, if you click on that, it'll take us to the game. Get it loaded up here.
Okay.
We're going to take no more than 15 minutes on this, but
there goes. All right.
Excellent. Okay, next slide. So we're going to kind of take this apart in pieces, and see what we can uncover about polar bears. And remember, I said it was kind of a dice game. So here we are. Polar bears, they come in pairs. They sit around the hole in the ice like petals around a flower. How many polar bears do you see? So basically what you're trying to guess at is how many polar bears are represented by the dice. And so what we're going to do is, we would normally go into breakout rooms, but because we have 1, 2, 3, 4 of you that are students. I think we'll just kind of stay together, but we're going to let you four kind of engage in the discussion and see what you can come up with for a guess. And just to kind of help preface this thing, if we had the 24 people or in your own classroom, you would want to put the students in groups of, and it'd be up to you, you know your students better than anybody, but groups of 3 to 5. And for this exercise, I think it's always a good idea if you can have an odd number if it works out that way. But for us, you will be one of the groups and we'll see where that takes us. What we would like you guys to kind of discuss, pretend you're 4 students in a group in middle school and look at this roll of die. There are 5 die. Is it a die or dice? I never can remember which way. Anyways, how many polar bears are represented by this roll of the dice?
1. I mean, 1 die representing 2. Anybody? Bueller? Anybody?
There's 1 pair. So is it 1 pair of polar
Here.
bears?
Okay, so this is a good place to begin. So tell me a little bit about your thinking on this. Where are you coming up with you said you think there's a dice represent a pair of polar bears?
The 1 die that has 2 dots would
Okay.
represent the pair of polar bear. And then I don't want to get ahead of myself, so I would leave it at that.
Are you inclined to agree, Eileen and Sue, if you're joining in? Do you guys want to agree with Kelly, or do you have a clarifying question that you'd like her to try and explain her thinking?
I was thinking that there's 2 threes, so that's a pair, and that represents a pair of polar bears. That's the way I was seeing it.
Mm.
So how do you think the line in the poem, they sit around the hole in the ice like petals around a flower? How does your thinking or reasoning on the number of polar bears represented by the dice reflect that line in the poem?
Then 5 pair plus the hole in the ice. That was a
Yeah,
question
you
I
could
had
look.
too. Yeah, was the 2 1 bear and the 4 a pair of bears? And then the 5 the pair of bears around the hole in the ice.
Okay, awesome. Sue and Kelly, what do you think of Eileen's reasoning?
I was thinking, I liked her idea about the 5 with 2 pairs of polar bears around the center, like the second line. But then going to the first line about they come in pairs, the 2 would be a pair, the 4 would be 2 pairs. And then when you look at the 3s, the center would be like the hole in the ice,
Yeah.
1 on each side would be a pair around the petal, just it's missing some other petals.
Oh
So I would
yeah, I
say
didn't see that.
1, 2, 3, 4, 5, 6, 7, 8. Now I counted 9 polar bears.
What do you
Yeah.
guys think of Tammy's thinking on that?
I didn't even see it that way. That's interesting.
Yeah, I love it.
So are you comfortable with that? Do you want to go with it?
Yeah, let's go with it.
Sure.
Okay, so we think that this roll of the dice then represents 9 polar bears. Okay, so just a quick question for you. Tammy, correct me if I got correct. Let me know if I got correctly. But what you said is that for the dice that have a hole in the middle or a dot in the middle, like the 3 and the 5, that dot in the middle represents a hole in the ice, and that the other dots represent pairs of polar bears. Did I get that right?
Correct.
Okay, now Tammy, you also though counted the pair of polar bears, the 2 pair of polar bears on the 4 and the 1 pair of polar bears on the 2, and you included them, didn't you?
I did.
Okay, but there's no hole in the ice there.
True. But I was looking at line 1 and line 2 as 2 separate requirements.
Okay. So Sue and Eileen and Kelly, you guys get to help. I mean, the 4 of you or 5 of you go ahead and decide which way do you want to go? You're gonna count them all or just the ones that have the dot in the middle?
I can tell you my students, especially the really smart ones, would be backing away right now going, oh, but we need definitions of things. We don't have definitions and we can't move forward without, they want the line filled in on the paper.
And what
That-
about the fish and the krill?
Yep.
Yeah.
Exactly.
Eileen, you have gotten right to the heart of sort of what modeling's about in that single observation. So way to go.
All right. I did it, part of my master's, I did how many colors are all the colors in the rainbow, and had a bunch of 6th graders talk about that. And boy, it was really hard, especially for the brightest kids.
Yes.
We got off into, is brown in the rainbow, is brown a color,
Oh,
it was
the brightest
interesting.
kids are used to having their thinking and used to getting that confirmation. And in modeling, we're going to make them reason with each other and come to the conclusion as a group. So you guys get to decide which way do you want to go?
I'm with Tammy.
Okay. So
Let's do it.
Tammy, we said 9 polar bears.
I think she
believe
did.
so. Yep.
Okay, cool. All right, moving on. Next slide. So in this cast of the dice, how many polar bears?
It looks like 9 again.
Mm-mm.
No, wait. 1, 2, 3, 4,
No.
6. No, 12. If the 6 in the middle of those are holes with 2 polar bears on each side, 2, 4, 6, 8. Oh,
But didn't we say that the dot in the center was the hole in the ice? So
mm-hmm.
the die with a 6 doesn't have a hole. So are we?
So what are they? Yeah, are they polar bears?
Yeah, we're still on polar bears.
Yeah, yeah.
Okay.
So the 3 is not 2 holes in the 6 is not 2 holes in the ice with a polar bear on either side.
I need 4 more.
It could be. It could be. Yeah.
What does the second line in the poem say?
They sit around like
Oh, flower.
petals
Yep,
around the
never mind.
flower.
Yeah, no, that's not it.
So then that's not it.
1,
So
2, 3, 4, 8.
We're gonna keep moving.
So this one would be 3, 4, 5, 6, 7, 8. And then the pair in the dice with 2. Are we still counting the pair?
Okay.
So when I had done it, I was counting a pair as 1 polar bear. So the 2 was a 1, and then the 4 would have been 2 more. So there would have been 3 pairs. 1, 2. I don't think I counted right on the first one then, because I was counting pairs of polar bears, not individuals.
yeah, you said
Mhm.
9. There were 9 pairs, right? That's what you meant?
Yeah.
Yep.
Okay. So then.
So how many pairs would be here? 1, 2, 3,
8
4,
pairs?
5.
Yeah,
5 pairs?
I agree. If we are defining it as
There's
we
a whole
have in the previous slides, yeah.
Right. Yeah.
Okay. So we have consensus?
1, 2,
Let's hit
3,
it.
5 pairs.
Everybody
Okay.
agree?
Yes.
Okay.
Cool. Next. All right. What about the fish? Now, we're still looking at the polar bears, by the way. So
Okay.
you could ask yourself how many polar bears are here based on the rule that you're using so far. How many polar bears are here?
4 pairs, would you all agree?
Yes.
Yes.
Okay. So 4 pairs of polar bears. How many fish?
What defines a fish?
6
Anything that's
fish.
not a polar bear?
That's what I would think. The ones that don't have a hole in the middle, each one of those would be a fish
So they
because
were
it's not counted in the polar bear. So I would say 6 fish.
six.
Okay, where do we find fish?
In-
In the hole.
So, no, seriously, I mean, the polar bear finds the fish in the hole, but in general, broadly speaking, where do we find fish?
in the ocean.
In the ocean, in a lake,
In
yeah.
the water, right?
Right.
In the
Okay.
water.
And where are the polar bears sitting?
Above them,
Oh.
above the fish.
Okay. So where are the fish?
Under
Below
them.
the polar bear?
Okay.
Oh.
Oh,
So
I
are
love
we,
that noise. Oh,
so are we
that's
thinking
beautiful.
that the fish is the number that's on the opposite side of the die?
But how could we tell how many fish there were? There could be twice as many fish as there are polar bear, right?
So explain that, Kelly.
So we can't tell if there are 2 or 20 fish underneath wherever the polar bear might be stationed around the opening in the hole. I mean, in the ice.
Okay, tell us why we can't know that.
Because we can't see below the packed ice and snow.
Okay. What do you guys think of that?
It makes sense.
Okay, what if I gave you one more interesting piece of information? And you're doing a great job in the role as middle schoolers, because most middle schoolers will not be aware of this, surprisingly. But did you know that opposite sides of dice always add up to 7?
That's right, they do.
And are we thinking that each dot on the opposite side of the die or dice is, each dot is one fish? So like on the opposite side of the 3, there would have to be a 4. And then another 4. And then a 2 for the die that's a 5. Am I thinking correctly?
I
That would
need
be
some more
true.
definition. Yeah.
Well, that makes sense with the theory that you can't see what's below the ice, and what's below the 3 would be the 4, since
And there
it's on
have
the
to be
opposite
more
side.
fish because trophic levels.
That's a brilliant student, David. Did you hear that?
We
That's
have a
phenomenal.
really bright one.
Every now and then I have a kid like that and I'll ask him
Yeah.
and it turns out dad is a virologist or something.
Yeah.
Exactly.
And when you run into that, one of the things that you probably want to do is steer away from the vocabulary, but it's absolutely fair to get them back to, do you think that generally speaking, there's more fish or more polar bears?
Or fish?
More fish.
Yeah.
Because a polar bear
They
would,
see that. Yeah.
yeah, they will generally get that. So using that line of reasoning and using what you guys have come up with, how many fish?
10?
18.
I agree with 10 because we're looking at the 3 dice that have the polar bears. So
Yep.
I was not
Okay.
counting the 4 and the 2
Okay.
because there's no polar bears there to fish.
Got it.
But why wouldn't we count? Because the fish will be there anyways, right? Would we count them anyway?
Good question. They're fish even if there aren't polar bears.
All right.
Are there fish if there aren't polar bears?
Well, you guys have done great. I'm already way over my time limit on this one, so I'm gonna go ahead and sort of call us done. But we've agreed that the dots that represent polar bears are dots that have a dot in the middle surrounded by, like petals on a flower, polar bears in equal number, like twos. So, and then all the dots on the bottom get counted as fish. Did we come up with those rules?
Yep, that sounds good.
Okay, and obviously there's more to this poem, and we can make this last a long time, but as I said, I'm already way over my limit on this one, so I'm going to stop. And Aaron, let's jump on ahead to your thing.
Sounds good. And again, I think it's fantastic that we spent that time on that process of thinking. So no worries here, David. I think it was great. So what did you notice? What were the organisms that were involved in the riddle?
What do you mean organisms?
So what organisms? There's polar bears
Mhm.
Fish and
Fish.
plankton.
mhm, and plankton, right? So if you could put those organisms in any specific order, what would that look like? How would they interact?
It's like a food chain. Polar bear eat fish eat plankton, plankton eat
Yeah,
bottom feeders, whatever.
yeah. And why do they
Sunlight,
interact? They interact because they are doing what?
feeding.
They're feeding, absolutely. So one of the things that we do is we try to use, I use this in my process of getting kids to think about interactions of organisms. So one of the things we start off with the MTA curriculum is exploring how ecosystems are organized. And one of the activities that we would do would be exploring biomes and having students in their small groups take a look at a specific biome and research organisms within that. Now, obviously, we're not going to do that right now, but that's something that helps start to bring the process of understanding, you know, where's my background knowledge going to come from? Where's my experience? Where's my phenomena going to come from? So the next part, then this is exactly what it would look like. So you would introduce these concepts of biome, ecosystem, community and population, and obviously organism, and then giving them an opportunity to explore and organize and create an ecosystem based upon those specific structures in the ecosystem. Does that make sense? So that'd be one thing to start the study of how ecosystems work.
Hmm.
Now, what we're going to do is we're going to do a small little activity. It's called Eat with the Flow. And this is going to be a very, very short component, but I think you'll see the actual evolution of it as we continue moving forward. So as you know, there's these levels, right, Aline? These levels that you heard about in our environment, and they're broken down by how organisms are organized. So producers is our first level, primary consumers, and secondary and tertiary, right? So what we want to do is try to figure out, how does this all work? Where do all these organisms belong? So some of the things you want to review with your students as you go through this is, producer, consumer, herbivores, carnivores, etc., and then decomposer. So the way I go about doing this in my class is I introduce these terms as we get through the progression of the unit. Some students already know these terms, some have no clue whatsoever. So in that process of building language in the modeling process, we ask students for evidence, and we ask students to show us how they understand what is a producer, what is a consumer, and so forth. So here's what I want you to do. Of the organisms that you see on the screen, what I'd like you to do is create a 4-member food chain, okay? And then label the producer and the levels of consumers. So what would that food chain look like? And again, you would be in a small group discussing and developing this and what you would want to do as your small group. What would you want to do first in your food chain? What would you be first?
Are you going with the producers? Are we looking from the bottom up or yeah?
How would you like to do that?
All right, team. What do you think?
That's right. It's team-based.
Emphasis,
That's right.
mouse, primary consumer, wheat seeds producer.
I mean, we could go from the bottom up. I have to draw it. I'm just a visual person. I have to do it.
Well, and while Kelly's getting her notes down there and the rest of you guys are kind of thinking, in the modeling classroom, one of the things that we love are whiteboards because they're easy ways for students to start to represent things that are not permanent on purpose.
Yeah.
Mhm.
And we exactly, we would be encouraging them to draw this out and represent it any way they wanted.
One of the things I also like to reinforce with our students is that our whiteboards aren't graded for accuracy, they're graded for
Mhm.
participation. So that fear of being wrong
Mhm.
is eliminated from the start. And that's that part of culture of modeling that we want to reinforce with our students.
I like that they can use a lot of domains too. They can draw or use words or, you know, show me
Absolutely.
relationships.
My ELL
Mhm.
students love to draw, and everyone loves to draw, but they have the opportunity to show what they know versus speak what they know.
Mhm.
Um, so how are we doing so far?
Pretty good.
All right.
Is a shrew just a little mouse? We don't in Miami, I don't know that we have any shrews.
Shrew is a very small relative of a mouse, yes. So it's small.
Yeah.
Some people call them field mice since they're that small.
Oh yeah. I'm a city girl. I'm like,
That's, that's okay.
I know the mice and the rats and possums, but
So what do you want to, Kelly, what did you start with as the first organism within your food chain? What did you start with?
I went to the very bottom to the worm.
Okay. So the worm. And then what was the second organism that you chose?
Wheat. I
Wheat.
could be
Okay.
totally off. I mean, I'm trying to think about like you would find the worms in the dirt around the wheat, so they would be repurposing and
Okay.
doing all that good stuff.
Awesome. And then what would be your third?
Well, this is where I was torn because I'm not quite sure how a rose plant got in there, but that's I'm trying to think about where everything was.
Okay.
But I was thinking about what might eat the worm would be the robin,
Okay.
but the mice and the shrew, if I were doing it by level, I mean, the shrew would eat the worms as well, so they could share a section, right? Are they allowed to in this exercise?
In this exercise, we want to try to stick with a linear food chain.
Okay.
So
All right,
you
somebody
chose,
else dive in here.
And
that's
Somebody
okay.
else dive in here.
you don't have to use everything.
Yep,
Oh, you
correct.
don't?
So four.
Just four things, just four. Yep,
Oh, that's right. I'm trying to make everything fit. That's
that's
my
okay.
problem.
No, that's what our students do.
Mhm.
They love to make everything fit. So this
That
is a
is so
natural part
fun.
of what we do in modeling is really try to reinforce that processing. So please, Kelly, do not feel that you did something wrong. This is exactly
No,
what we
no.
want to hear and want to see. So
Perfect. So
I,
then I would go worm, wheat, robin, cat.
wonderful, fantastic. So worm, wheat, robin, and cat. Fantastic.
I mean, so many
So,
other things would fit in there, but let's just go
oh,
with that.
absolutely. Absolutely. Do we all agree with that, Tammy, Eileen, and Michelle? We're good?
Yep, that's good.
Yes.
All right. Fantastic. So again, what would happen after we'd explored those food chains is we now start taking a look at that food web, right? So we're going to bypass this component slightly, and we're going to talk about how energy moves within that pyramid. So we're going to adapt this instead of using an actual food web that you would have created. Let's talk about our food chain. So you said that we would have the worm, right, Kelly? And then we have
Mm-hmm.
the wheat, robin,
Mm-hmm.
and then cat. Does everything fit within our food pyramid at each level?
I think so.
Anybody else? We agree?
Yes.
Okay. So here's my question. If the worm is in the bottom part, what would we call the worm? What does the worm do?
I wouldn't put the worm in the, well, I would put the worm not in the bottom one.
It's
It's not in the bottom. So you'd like to
Yeah.
change your model of how your pyramid would look.
I'd put plants in the bottom.
You put plants on the bottom.
Like the
Okay.
rotting leaves, yeah.
yeah.
So maybe put down below, instead of the worm, the wheat.
Mhm.
And then after the wheat, you would put the robin?
No,
No,
the
okay,
people who live straight off of the plants,
okay.
which
So
could
those would
include the
be,
decomposers,
which would be, sorry, I'm
like the
shooting my screen here for you.
worm.
The worm.
So in our next level, so we had wheat, and then the next level would be whatever eats that would be the mouse, right? So wheat seeds, that's what it eats. Oops, the wrong way. I'm so sorry. Oh, my fingers are going too fast. Sorry.
Are you asking Eileen or me?
The whole group.
Oh,
So if we put wheat down below,
mm-hmm.
and then we have a mouse, would a robin go here in the third level?
Yes.
No,
No,
it's
because
above.
the robin
above that.
doesn't eat the mouse.
Yes, right.
The robin wouldn't consume the actual mouse. It would have to be another
Mouse.
organism, right?
Was it what does the badger
Yeah.
eat mice?
Mm-hmm.
No,
the
So the
cat?
badger eats shrews.
Oh, true. Okay,
Right,
so
so
the
we could,
cat.
okay, so then the cat would be there, right?
Mm-hmm.
So there is a unique way that we set up the food chain, right? So we started with wheat, and then we went to the mouse, but instead we noticed that nothing really eats the mouse. We would have to go to the shrew, correct?
Mm-hmm.
So then from the shrew, what eats the shrew? A badger,
Badger.
Mm-hmm.
right? The question becomes is, what eats the badger? A cat?
The,
I don't know.
well,
Nobody on our list. Yeah.
I'm nothing on, yeah, nothing on the list.
Nothing on the list.
If
Yeah.
it dies, maybe it would decay and worms would eat it. I don't know.
Okay, so but worms wouldn't be at the top of the food chain or food web, would
Mm-mm.
they? Right?
Yeah.
Okay, so then we would actually go back, revise our food chain as a process of another iteration. So this modeling
Right.
cycle continues through this process of negotiating. Okay. So again, the purpose was not to confuse. The purpose is to try to pull away misconceptions, pull away understandings of what the phenomena shows us. Does that make sense, everybody?
Mm-hmm.
You feel good about that?
Mm-hmm.
Mm-hmm.
Awesome. Fantastic. Now, a part of this whole process is getting to that decomposer, right? So what does why is the decomposer so important?
Because
Because
of the
it breaks
recycling of nutrients. Yeah.
So basically they break things down back. And what do they give back to the environment?
The
Like
basic
she just said.
macronutrients.
Yeah.
Ooh, macronutrient. So what do those nutrients give us?
energy.
Oh, beautiful. That's perfect.
Yeah,
I'm
that's
gonna
a good
pay
way to put it.
$5 for saying that words. That's awesome. So energy, right? So you could take a look at the flow of energy, right? Within our first level to second level. And this is again, the process of refining our understanding of a ecosystem, right?
Mm-hmm.
But our most important part is trying to see how dynamic our ecosystems are. And what we want to do, a part of modeling, is seeing the interconnection between the different concepts of life science to physical science. So one thing that we have for you is a connection of how energy moves throughout the system. and we call these energy bar charts. So
And, yep,
let's
and for
go
those
ahead,
of
David.
you that, thanks, Ed, let me just kind of jump in with this. So, and for those of you whose districts are using the next generation science standards, you'll remember in cross-cutting concepts, number 5 is energy and matter, how energy flows, energy cycles, tracking fluxes of energy and matter into and out of and within systems helps one understand the system's possibilities and limitations. So this feeds directly to that, along with patterns, cause and effect, and we could go on. You can kind of see how it's systems and system models. So how to quantify and represent. So modeling uses this particular technique throughout the program as a way to try and help kids get the idea of energy and its role in our world and our lives. And so going back to our food chain, an owl eats a mouse that has eaten a pile of wheat. How can we represent that? Not thinking about the mouse and so on, but just in specifically what's happening with the energy in it. So we would have the kids draw the food chain for the organisms, wheat, mouse, owl, and then we'd talk about it, get them to, sort of give a good explanation. We wouldn't give the explanation, we'd try and get them to do the describing. And then we would get them to represent it on this. And sometimes we call these LOL charts. If you ever hear that term, the 2 graphs are made up of an L, and then in the middle is the energy. And we're trying to get them to understand that energy goes in and energy goes out. And this also helps them get this idea of what happens to the energy and how it's conserved and how it's used. So representing that first relationship with the wheat. So initially the wheat has 100% of the energy and the mouse has how much energy? The poor mouse is hungry, but he has not eaten any wheat. So of the energy that's available from the wheat, all of it is contained in the wheat, right?
Mhm.
And the mouse doesn't have any. So what direction is the energy going in this particular representation? Is the energy going to go into the wheat or out of the wheat?
Out.
Out.
Out. So we just draw a big arrow showing that the energy is going out. And then we represent the new relationship. So if the mouse is eating the wheat, how much energy does the wheat now have?
None.
None. And this is one of the key concepts. So the mouse eats all the wheat. Does 100% of the wheat's energy go into the mouse?
No.
No, not really.
No, a lot of kids will think so. And that's one of the challenges that we have. But we want to try and get them to understand how these systems actually work. Only about 10% of the energy from the wheat goes to the mouse, and the rest we say is dissipated. It kind of goes back into the systems. All right, any questions so far? All right, so guess what we're going to do next? If we just did the wheat, now we're going to do one representing the
owl.
So now the mouse system, the mouse has the 100% of the energy, and what's going to happen to the mouse? He's going to get eaten by the
Owl.
owl. So the energy from the mouse is going to go to the owl, and using our rule of thumb about how much energy goes of the mouse ends up in the owl.
Yeah,
So what
tiny amount,
happens?
a tiny amount, 10% would
Tiny
be
amount.
huge.
That's fine. And
Yes.
again, so don't get hung up on, do they have the bars all exactly at the right level and stuff. We're trying to get a large sort of, generalization of what's going on. And the energy goes either into the mouse or out to the mouse.
Out of the mouse.
Out of the mouse, right? So the circle, we put the mouse, because that's the system we're looking at right now, and the energy is going out. And the rest of the energy, because we want to represent all the energy, is anybody? Dissipated, right?
So for middle school, this is actually, if you're getting kids developing this forth thinking of how energy moves, you are getting your kids beyond where they should be in 7th grade or 8th grade, because this is a huge connection where they need to be getting into high school for like biology, chemistry, and physics. So introducing this concept is huge for the kids to get that well-rounded understanding of how energy and matter and life cycles and ecosystems work. So if you were doing another example, you can give them basically like another word problem. So, sea turtle population eats the moon jelly population. And again, obviously the moon jelly population eats the plankton. So again, another food chain, right? And you could use this again in an LOL and look at each component of that food chain. So the sea turtle eats the moon jelly, and you would represent it this way. So the turtle and the jelly, and then the easy would be the zooplankton. So what specifically would you be looking at? You would put that organism in that circle and then show the bars of how they would work. So I don't think my bars are going to work, but since I'm sharing my screen. But again, this is just something that you can practice and use. And there's wonderful resources in the AMTA curriculum that has multiple examples of these. So that's pretty much it for our bar charts.
Interesting.
We think so. Thanks. All right. Aaron, you want to hit this one, and I'll
Sure,
get the
absolutely. Absolutely. So the key ideas of modeling in our modeling cycle is observing phenomena or how you represent that phenomena. For example, the polar bears, we use the dice as that symbolism of how we see polar bear and fish and plankton. Reveal that idea of what the students should be looking for. Challenge the model. We were asking you to go through that process and figuring out each cast. And again, the same idea with the food chain. Where would you want to put those specific organisms within those different levels? And then as you progress through that cycle, you're continually updating, adding more context, adding more depth as the students unfold even more misconceptions possibly, or simply just continue to dig deeper with more advanced phenomena. You deploy that model continually as you go through. Until you hit that snag, you continue to challenge that model as the students grow. And again, assessing the veracity of the model, again, that's all a part of that dynamic we want our students to struggle with, and us being that guide for them through that cycle. The modeling characteristics, obviously, you saw that student-centered. It's very inclusive. It pulls everybody in. Again, phenomena-based and focused. And the curriculum really is structured to capture conceptual models rather than just topics. So in other words, seeing how that food chain went straight into the idea of how energy is used in the actual LOLs. And lastly, activity before concept. I know I shared the vocabulary with you early, but I wanted to show you what we were getting at with that activity beforehand. So tools of the trade.
So, as Aaron said, we always work with some kind of observable phenomenon, and then we use it's a critical part of what we're doing here, that students are working in groups and collaborating, and that happens in small groups of 3 to 4, like we did today, and then we would take those groups and have those groups interact with each other in what we refer to as a board meeting. Where they then challenge each other's thinking, challenge each other's models, and challenge each other's representations to try and come to a large group consensus about what a good rule is that will work for our model. As we talked earlier about, we use whiteboards extensively to help kids represent their thinking, and then to be able to share their thinking with other students, other groups of students. And we call those board meetings. They're basically Socratic dialogue and talk moves. And in a modeling training session, there's an extensive a bit of help with teachers using and working with students doing Socratic dialogue. Do we have any? I don't think.
What I'll do, David, I'll share some of my boards as we handle any questions from the participants. How's that sound?
Awesome. So I was sort of looking through the chat. I didn't actually see too many questions there, but you guys can go ahead and feel free to bring them up now as we're kind of talking. Aaron, you want to just talk about the quick structure of the
Sure.
curriculum?
Yeah, so taking a look at the AMTA curriculum, sixth grade, again, you notice that it deals with a lot of different concepts between earth and life and physical. And there's each of those grade levels tries to build in complexity as you go through. So bodies of water, life in the bodies of water, the interrelationship between those units help students develop a deeper understanding of how things work together. I mean, things in science do not work in isolation. We see the interconnectedness of them, and that's the most important part with the AMTA curriculum. Um, and I'm going to I'm going to escape here, and there's questions. I'll come back. I'm going to stop sharing my screen for the time being. I'm going to pull up some of my whiteboards that I want to show you. Okay.
So while Aaron's kind of doing that, I'll just brag on Sue a little bit. Sue is the principal genius that does 90% of the work for our organization. Okay, she's saying no, but she's also anyways. There are lots of ways that you can learn more about us on our website, and some of the social media links that you saw there can get you keyed into people that can help give you some direction. AMTA offers quite a variety of classes, from middle school modeling up through more detailed high school courses in astronomy and mechanics and chemistry and physics and so on. Sue can brag on a little bit more on the different courses and how you can learn more about it.
Absolutely. Modelinginstruction.org is our website, a link where you can find all of our workshops this summer. What I did put into the chat earlier was the astronomy middle school workshop. It's all the way at the top. There's a link to that. There's also a distance learning short course. It's only 15 hours. It's worth one graduate level credit, called Reimagining Energy in Middle School Science, using, pardon me, modeling instruction. That's from March 16th to April 13th. So if you scroll up in the chat, I put the link to that as well. We are currently trying to get a middle school science modeling workshop in Sacramento, California this summer. So keep checking back on our website. There are some possibilities coming up with middle school science. If anybody's interested in hosting a workshop, we can help you host. We can find you trained leaders like David, like Aaron, and they'll come out to your location. We can work on setting that up for you if your district would be interested in hosting.
I've included my contact information in there. If you find that you have questions later on, feel free to contact me either through email or a text message or a phone call. Any are welcome.
And I'll add mine in there as well. I'll show you a whiteboard that it's not exactly ecosystems. For some reason, when my students saved it, they saved them upside down. So I'd rather you not see upside down. But but I'm going to put my contact info in for you as well.
So Aaron and I both also happen to be on the board for AMTA. Aaron's the treasurer and I am the president. So if you have other kinds of input or questions, don't hesitate to reach out.
Absolutely. So I'm going to share my screen with you and get over to whiteboards. Here we go. So what you're seeing is a whiteboard from one of our diffusion labs where we use dialysis tubing, and the students do a test with glucose and starch, and they run through a battery of tests, and we share data. So each group has a different variable that they're testing. And they go through and they share their results. And then that's how we have one of our board meetings, to try to find patterns within our data to see what would show up. We also find inconsistencies. Are there errors within what happened in the lab? And sometimes, there's holes in dialysis tubing. There's things that just don't work out right the way you expect it to. And that's just called real science, right? So this is an
Right.
example of what a whiteboard would look like. And their claim is very straightforward. It's simple. It's not supposed to contain a because. It's simply stating exactly what they found and then the evidence and reasoning to support that. So this, to me, is the bread and butter, the meat and potatoes, the everything that goes into a whiteboarding process. And for professional development, we go through and we implement so many different experiences with whiteboards that you really get a good sense of how it works with life science, earth science, and physical science for a middle school modeling workshop. And then myself, I've done the biology, the mechanics workshops as well for high school. And those are phenomenal in the sense of understanding where my middle schoolers are going to go and what they're going to experience from a high school level. So it's kind of nice to feel like I know where they're going, and reassures me that uh, I'm setting them up for success.
Mm.
This is good. Claim evidence reasoning is one of the hardest things that we go over with the kids. They just have a really hard time. And of course, that's why we're doing NGSS, so that we can do more expository writing like this that makes sense. But it's a foreign thing to them.
I just had a disaster of a lesson on Friday based on writing conclusion statements about a lab that was a very simple physical or chemical change lab. And they all want to write like it's an English class. And it's
Mhm.
so frustrating. And I think that this is going to be very helpful, but, and I have very high achieving students that are all very deliberate. And they're like, they take everything you say. There's no room, there's no wiggle room. They think if you say, one sentence, that's how everybody should write that one sentence. They don't want to step outside their comfort zone because all they want is the A.
Yeah.
That's
Yeah.
why modeling instruction is so fabulous, because it teaches them to think for themselves. It teaches them to
Mhm.
speak when they're in their whiteboard meetings. They have to be able to present and explain. So they're thinking, they're communicating, all of those skills that we want them to have. It's really life
Yeah.
changing.
And part of
I've
the
been
process too with PD is we actually go through the pedagogical understanding behind all of modeling too that really supports you in helping other colleagues understand. So we try to create an opportunity for you to have leadership opportunities too with the workshop.
Mhm.
Very good. Any questions?
No, this is great. Thank you.
Yeah, thank you very much.
Well, thank you guys for joining us. This has been the funnest night this week for me. So there is a QR code up for a survey, and we would really, really appreciate if you just take a few minutes to share your thinking with us, and that helps inform the work we do in the future and helps us improve the model that we're putting together.